Hi, today's lesson is on multiplying and dividing rational expressions. Now, what is a rational expression? Basically, it's a polynomial over a polynomial, or number over a number, or an x over an x. It doesn't matter what you call it, it's just a fraction, in other words. It's a fancy thing for that. So, with fractions, we can get equivalent expressions. For example, this can be reduced, if you will. So, how do we do that? Well, 12 over 16 we know is basically 3/4. But if you want to know more detail, we can look at it as 2 times 2 times 3 over 2 times 2 times 2 times 2 if we break them into their factors. And basically to reduce, all we do is cancel what's the same on top and bottom. Whatever we're left with is it's an equivalent expression or reduced form. So we're going to do the same thing with this. We're going to break into its factors and then see what's the same on top and bottom and cancel. So if you take a look at this one, they all share x's. So we got x. On the top we get x squared minus 5x minus 24 over x squared plus x minus 72. And if we factor these, we get x minus 8, x plus 3 over x minus 8, x plus 9. And basically what happens here, whatever is the same on top and bottom cancels. So the x's cancel, the x minus 8's cancel. So our final answer is x plus 3 over x plus 9. So all we're going to do is just factor and cancel. Go ahead and try this problem. Okay, to simplify a rational expression, the same thing as reducing it or canceling what we just did. So there's a key trick here though. Notice the x is after the number. So how do we fix that? It's actually quite simple. All we got to do is flip it and put a negative in front. So if we're going to rewrite this, we write negative x squared minus 4. So in other words, when I flip like this, it's going to be negative in front. And then finally, I'm going to rewrite the bottom. And now we're just going to go ahead and factor and cancel, keeping the negative. So this would be x minus 2, x plus 2. And this would be x plus 5, x minus 2. And what's the same on top and bottom? The x minus 2's. So our final answer is negative x plus 2 over x plus 5. And I like to pull the negative out in the front. Go ahead and try this problem. Okay, so now we're going to multiply. Multiply is the exact same thing. All it is the fraction separated. So let me show you what I'm talking about. So if I have 2xy over z times 3x squared over 4yz, all we have to do is cancel whatever's on top and bottom, and we can cross cancel. So for example, can 2 cancel with anything? Yeah, I can cancel with the 4, so it's 2. There's no x's on the bottom. There's a y on the bottom? Yeah, there's a y on the bottom. So we cancel everything we can. There's no 3, no x, we're good. And now we combine what's left. So we get x cubed, 3x cubed, excuse me, over, there's 2 there, so 2z squared. And that's it. Go ahead and try this problem. Now, what if we multiply these crazy polynomials? Well, what we do is we factor everything and then see what cancels. So I'm going to start with each individual part. So 5x does not factor. Neither does x plus 3. Now we're going to factor this one, which would be x minus 3, or x plus 3, excuse me. And then x minus 2. And then the bottom one would be x plus 1. x plus 1. Now do the next term. These just have x's in common, so it's x plus 1. And then that one has a 5, so 5x minus 2. So we factor each individually, and now we get to do the fun part, which is cross everything we can. There's an x plus 3 on top and bottom. There's one of the x plus 1s, not both, just one of them. X minus 2. And that looks to be it. Oh, the 5s. 5s cancel. So we're left with an x on top and an x plus 1. And that's it. So really, you're not multiplying, you're just more factoring, canceling more. Go ahead and try this problem. Now, what if we multiply by a non-rational expression? Basically, you just treat it as though it's on top. So we're going to do the same exact thing we just did before. So we get x plus 2, factor the bottom, which would be x squared minus 4, x squared plus 4. I'm going to go ahead and divide out the x here for this one. So we're left with x squared plus 4x minus 12. This is all over 1, if you will. I still got more factoring to do. So I got x plus 2. And on here I got x minus 2, x plus 2. But since this is a plus, we don't mess with it. We just leave it be, because we're not going to deal with imaginary numbers. Factor this one. So x plus 6, x minus 2, all over 1. Now we just cancel what is there. So x plus 2's, x minus 2's. I believe that's it. So we're left with x plus 6 over x squared plus 4. Or if you want, you can multiply it back in. So x squared plus 6x over x squared plus 4. Go ahead and try this problem. Now division. Division, hopefully you remember, is when you do fractions, you must flip the second one, change it to multiplication. So I'm going to do that while factoring at the same time. So if you notice, this is a 1, 3, 3, 1. So that's a cubic function, cubic expansion. So this is going to be the same as x plus 1 cubed. The bottom, we got to flip, make it negative. So this will be negative x squared minus 1. I'm going to go ahead and change this. I'm going to factor the bottom. So x plus 4, x minus 1. And I'm going to factor the top, which is x plus 4, x plus 1. So in other words, I flipped these while I factored. So this one's on the bottom and that one's on the top. And now basically I'm going to factor some more. So I got negative. I'm going to go ahead and write this 3 times just because I like doing that. So x minus 1, x plus 1 times x plus 4, x minus 1 over x plus 4, x plus 1. And now we just look what's same on top. So that one cancels. That one cancels. Nope. These cancel. This one cancels. So we're left with a negative x plus 1. Or you can rewrite it as negative x minus 1. So the key thing here is flip the second one. All right, try this problem.